Hi everyone, my name is Lavakumar. Thanks a lot for coming down to this talk. I can see it's very crowded, but try and make yourself as comfortable as you possibly can. It's good to see that you have left some room here so that if somebody finds the talk really boring, they can run away from here. So that's good. So guys, unfortunately, Ankita couldn't make it. She had some prior engagements. Like this is a flashback talk. So the last time I gave it was in 2014. Back then, Ankita was single. After that, she got married, and now she is going to her relatives' marriages. So she couldn't make it this time. So you're stuck with me. A little bit about myself. I'm the founder of IronWasp Security. I don't know if you've heard about IronWasp. It was open source black box scanner I developed back in 2011. Back in the time when I was still actively developing it, it was very popular, one of the best in the industry. I've been a security researcher and a penetration tester, and I've developed a lot of offensive security tools. And I've developed a black box scanner. I think I'm one of the few people in the industry who has developed a black box scanner, which is a DAS, developed a static code analyzer, which is a SAST, and also developed a IaaS product, right? And I've also been a manual pen tester as well as a security researcher. So I think I have touched on different areas. So I'm probably a little qualified to give this talk. Before we get started, I would just like to understand the audience a little bit. How many of you work in consulting firms? You do pen testing in consulting firms? Okay. How many of you work in actual product companies? You do internal pen testing for your product which you developed internally. Okay, that's good. Because this talk would actually make more sense if you were working for a product company versus if you were a consultant who's doing pen testing for somebody else, right? So just setting that expectation for you. Now, while we look at, before we get started in the talk, I would want to clarify a few terms. I'm going to use DAST in multiple places. Now by DAST, I basically mean a black box scanner similar to burpsuit, AppScan, Acuanetics, and all of them. SAST is a static code analyzer like checkmarks, Veracode, and the likes. And IAST is interactive application security testing. I'll explain what IAST is and how they work a little later in the talk, right? Okay, so when we talk about DAST, as a person who has done both manual testing, who has led teams of testers, and who has also developed a black box scanner, I would say that a DAST-based vulnerability scanner is on average more efficient, more effective, faster, and cheaper than a manual tester, right? I mean, I'm essentially saying that it's better on average than a human tester, which is a controversial statement because obviously human testers have more intelligence than an automated scanner has. But again, for certain category of vulnerabilities, when you look at the number of combinations which an automated scanner will look for versus what a manual tester will look for, and then when you factor in the distribution of skill, which is you have highly skilled testers, and then you have testers with low level of skill, and you have testers who are good in say one class of vulnerabilities but not so good in another class of vulnerability. Like for example, you might have someone who has a lot of expertise in SQL injection, but they might not be very good in discovering another type of issue like cross-site scripting, for example, right? So when you factor in all of those variations, I would say that automated scanner is on average much better than a manual tester. Okay. But then again, there's a problem, which is when it comes to coverage. If you cannot access a particular section of a site, then then an automated scanner cannot even test it, right? Like for example, if you cannot see it, then you cannot analyze it at all. And when I say coverage, I'm talking about discovering functionality on the site. For example, let's take the case of this site Yatra, right? So here you have like a small functionality, which is you'll have to select a from and to destination of where you want to fly, and then you will have to select a departure date and a return date, right? So this is a simple functionality for a manual tester to access. But then if a tool were to automatically crawl to the section of your site, then it would not be able to populate it properly, right? For example, it might pick a from and to destination where there are no flights at all. And then when you click on book flights, the functionality might not work at all. And if it's picking a departure and a return date, it might pick a return date which is probably earlier than the departure date, right? So it might do things like this, because of which it might not be able to get to the next section of the site, and then everything after that is completely lost. So an automated tester, a DAS tester which does crawling, and it's trying to discover your site, cannot get past this particular section of your site. And then, even if you do trigger your functionality, right? Then what kind of data you send to that functionality is also equally important. For example, let's take a simple login form. It's asking you for username and password. Okay, I'll stand a little to the side so I don't block the projector. Okay, it's asking for username and password. And if you're a manual tester, you're going to try single quota 1 equal to 1 or payload similar to that. And if you're running an automated scanner, that's also going to try payload similar to this, okay? Which should work in a lot of cases. But what if the functionality is written like this, which is the application is first checking if the username is in the form of an email, right? And it's not in the form of any email, it's in the form of an email of that particular company, right? So for example, if you work for flipkart.com, then the logic checks if the email address is actually, @flipkart.com, right? Only then it actually proceeds to put it in a SQL injection, a SQL query. In that case, only if your payload is in a certain format, will that vulnerability even get triggered? And an automated tool will not be able to know this because it doesn't have that knowledge about that particular application, right? So this way you have another problem, which is even if you do crawl and get to a section of the site, just because you don't know what is the right data to populate into that field, you might not trigger that functionality. So even though the scanner's logic is really good, it might not be able to discover vulnerabilities there. Okay, so I and Ankita, we back then she was a functional tester, so she was doing Selenium-based test automation. I was developing IronWasp, which was the open source DAST scanner. So I had faced this problem. I was trying to get better coverage through my crawling, and she came to Nullmeet in Chennai. So we spoke with each other, and we are like, hey, you have a functional test case which has all knowledge about the different sections of the site, right? Which has been filled in by a dedicated team, either of developers or of testers, and then it's accessing these sections of the site with actual valid data, right? So both the problems I face with an automated crawling is in some way present inside these functional test cases. If only I could take it and make use of it from my scanner, I can get the best of both worlds, right? So we tried to do a marriage between IronWasp and functional test cases. I exposed some APIs from within IronWasp, which can be called from the Selenium script. So essentially what will happen is you run your Selenium scripts through IronWasp, and IronWasp would in some ways kind of record those scripts, and then it will replay it and it will do the scan, right? So that's what we ended up achieving. And it had good results. It had good interest as well from users. So we got better scan results when compared to just normal crawling by doing this marriage. But then again, it has its downsides as well. It wasn't perfect, which is one is about stale data, which is to say that you can run the test case once, but there are certain sections of the application where once you send a data, then it becomes stale, right? So if you're going to resend it again, because if you're looking at a vulnerability scanner, IronWasp, for example, just for doing SQL injection vulnerability detection, it used to send at a minimum of 50 to 60 payloads, right? And if the application behaves in a certain way, then it will start probing more, so it could send up to 120 payloads per parameter just for one vulnerability, which is SQL injection, right? And if you factor in all the other different vulnerabilities you have, you're sending hundreds of different payloads for every parameter. And if you take one request, then you have several parameters, right? So we are sending thousands of requests just to scan one, page in your application. So if after the first few attempts, if your data becomes stale, then the rest of the scan doesn't really trigger the functionality. So it just goes blind. And then you have state change again. You make a request, and then something changes in the application. So you'll have to refresh and send, for example, a CSRF token. If you don't handle that properly, then it's of no use. Session management and scanning time. Like I said, because we are sending a lot of different payloads, thousands of payloads, in fact. So the scanning time is really long. So to manage session, if I were to replay the Selenium test case to get a fresh session and then do a scan again, then it exponentially increased my scanning time. Okay, so these were some downsides we actually saw by, even after doing this combination of automated Selenium test cases as well as the DAST-based scanning. And since then, software development has evolved as well, as most of you know. We are in the era of, continuous integration and continuous development and deployment. So essentially what happens is, your developers, now everything has moved to the cloud. You're not pushing, like monolithic pieces of software anymore. Everything runs on the cloud and it gets deployed there, in a very continuous, agile manner. So every time a developer, he writes a new piece of functionality, he pushes a commit, then this commit gets, integrated with the main branch, and then there's a bunch of tests which run automatically to check if it's functionally proper and if it's not breaking any functionality. And if the functional tests pass, then it gets deployed in an actual, environment, and then it gets pushed into the live environment as well. So, which is from the developer's machine to running on a production, site, the whole process has been completely automated, right? And it can happen like in a matter of a few hours. So software development has changed quite a lot, and in this speed of development, you cannot have manual intervention come in, which is to say that earlier you could have a combination of your DAST as well as manual testing, which is you run a DAST-based scanner, and then you also do manual testing for those sections of the site which you think are a little complex and your DAST might not be able to scan properly. But right now, with the speed of software development, that is not really an option, because you're pushing code into production almost on a daily basis, and you cannot have your testers come in every time there's a commit, come in and test for that particular section of the code. It just doesn't work out logistically. Although the testers have the skill, you could still do that, but just logistically, it's a big, the human element becomes a big, you can say, bottleneck. So what if we can magically discover vulnerabilities just when the functional testing is happening, right? So rather than running the functional test once and then based on that get information about the application and then put it into a DAST scanner and run these different fuzz cases, what if while your functional testing is happening, what if vulnerabilities could be detected automatically, right? That would be an ideal scenario, and that is where the industry is going as well. And that's where IAST actually comes in, right? So IAST can actually enable this for you, and I'll explain what IAST is. Anybody here has already used IAST in their company? You have an IAST product, or you have explored an IAST product? I'm sure somebody would have pitched an IAST product to you. Any show of hands? Okay, 2 people, like 3. Okay, nice. So IAST, it's probably not that prevalent yet in India, I would say, but then it's slowly gaining traction, and that's where the industry is headed as well, and you will understand why. So it's an evolution of your DAST and SAST. If you look at your DAST tools, what they do is they only look at the HTTP request and response, right? And they do all their analysis based on that. So for example, you send a request to the server sends back a response, and looking at this request and response, you try to find vulnerabilities, but the tool doesn't know what's happening on the server, it doesn't know what's happening on the client, right? So those are black boxes as far as the tool is concerned. So there's a lot of guesswork going on. That's why it has to send multiple payloads. That's why you have false negatives. That's why you have false positives as well, okay? But an IaaS system is something which is not looking at the request and response, but it actually sits inside your application. So you have a sensor essentially in most of these cases, and the sensor would either be on your server side or it would be on your client side. And while you're interacting with the application, it can actually see what is happening inside your application. And that's how it discovers vulnerabilities. And this is a fundamental change when compared to DAST and SAST. So let's say this is a normal application where you have a SQL query constructed by your app, taken from user or taken from somewhere else. And then this SQL query has been put into an execute SQL statement. Okay, this is a normal application. Now let's say this application is now being monitored by an IAST engine, right? So the different ways in which an IAST engine can attach to your application. But in whichever way, if it's being monitored by an IAST engine, then this is what happens, which is the IAST system will essentially inject itself on all critical APIs inside your application. So when there's a SQL query being executed by your developer, then just before the SQL query is executed, this gets analyzed by the IAST system, right? And by this analysis, it tries to discover vulnerabilities. Now, in terms of how it will discover vulnerabilities through this analysis, there are different ways of doing it, and it depends on the vulnerability category as well. If you're looking at vulnerabilities like SQL injection, for example, now a SQL injection is a problem if you have untrusted data coming from user controllable sources, and then if it enters into a SQL query, then that's considered a problem. Okay, an IaaS system might do runtime taint analysis, which is to say that whenever an untrusted data is read, it might attach a taint flag to it and it might propagate the taint flag, all through the application's execution. And then when at this point, it sees that the SQL query which is going into the execute statement, that particular API, if it sees that it has the taint flag, then it will say that, hey, there is actually untrusted data going into your SQL query, and it might report it as a vulnerability. So that is one type of an IaaS system. There's another way is they use static analysis to actually get this taint information, which is to say that the IaaS system would have done a very quick static analysis of your app. So it knows, from where data is taken and where it goes. And then it'll correlate it with the actual runtime data. And then it sees that, okay, for this particular code path, it's actually a tainted data. And then, from that case, it'll see that, okay, as per my static code analysis, it looks like tainted data should come here. And then in runtime, it actually sees that, data from the request enters there. Then it kind of correlates both of them, and then it'll report it as a vulnerability for you, right? So, but in either case, because it relies on runtime data, and because it's doing it when your application is actually executing, you do not have to send any payloads. All you have to do is access that functionality once. And when that functionality is getting access, the IaaS system can automatically discover a vulnerability and report it to you. Okay, so IaaS system can find issues which are missed by DAST, which is, one is the issues DAST will miss because it's not able to get proper coverage. That, when you're just running your functional test cases, the IaaS system can find out. The other thing is it can find issues from categories, entire categories which a DAST system cannot even look for. I'll just talk about it a little later. And in these categories which a DAST system doesn't look for vulnerabilities, your SAST tool might pick up vulnerabilities like these, but then IaaS performs better than SAST also in certain cases. I'll just give a few examples. For example, you have issues which will rely on runtime data to actually discover if it's a problem. Like for example here, can you see if this is actually a vulnerability? Now look at this piece of code and tell me if you think this is vulnerable. Let's say you're doing a manual code review here. Sorry? Timing attacks. Okay. How is that? How is it susceptible to timing attacks? I don't get it. Mm-hmm. No, there's no comparison here. There's no comparison. Yeah, that's assignment, yeah. Right, yeah. Which is, just by looking at this code, you cannot say what algorithm is being used for hashing, right? Because that information is being read from a text file, and that text file might differ depending on the environment. For example, in the local developer's machine, there might be one text file on your UAT environment, the text file might be different. So this information as to what hashing algorithm is used is only available during runtime, right? And a static code analyzer cannot pick this up, and because it's a crypto-related vulnerability, a DAST tool is never going to pick it up anyway, right? So, but then, because an IaaS tool actually hooks itself into all the critical APIs, and it knows what parameters are being passed to those APIs. So whenever that particular API is called, at runtime, whatever algorithm, whatever string is passed as the algorithm, the IaaS system will know about it, and then it can tell you, hey, you're using an MD5 hashing algorithm, or you're using a SHA-1 hashing algorithm, right? So that's one way in which it can be better than SAST. And then another thing is like this. For example, here, do you see any problems? Let's say your application has a logic like this. Do you think this could be a problem? Or if you saw this in your source code review, what would you do? You're not able to see it? Okay, unfortunately, I don't think I can do much about it. Yeah, to make it worse, it's an image. I cannot even put it in a notepad. Okay, so I'll just read out what's going on. So you take a parameter from the request, and then that's actually data coming from the user. And what you do is you take a property from your database, and then that's a URL. And what you're doing is you're making an HTTP post call from your server, right? You're calling a service from your server. The URL for that service comes from a property, and then the data that you're sending to that service actually comes from the user, okay? So that's the rough functionality. If you see this, sorry? Data is not validated, okay. What's the other thing? Right. So yeah. So this data we're putting it here. We're not validating it. Okay, that's one thing. Anything else?
We can use different data, different information to get the user information will be accordingly.
You're saying the user can send different kinds of data and like modify what goes in here. Okay, that is true.
Depends on like what is happening in Postgres is the request body.
Sorry.
Command inject crafting the request.
Yeah, it puts it in the body. Yeah.
It depends on the URL what is that for.
Right. Okay.
You can definitely fuzz it. You can
You will fuzz this parameter, right? Okay. Anything else?
You can pass the data and execute something which is unexpected user data.
Right. Right.
like line terminators is high level.
True. You can do all of those things, but that's all from a fuzzing perspective. But there was something else I was looking for, which is you are taking data from your user and you're actually sending it to another service, external service. Now, if you have like looked at GDPR and things like that, there's a lot of concern about who you send data to. If you're sending data to a third party, and that too if the data is your user's data, right? Sending it to an external service is a big concern. Now, in this case, if you look at it, of course, you can fuzz it. You can, fuzz. It's almost like you can say like a little bit of a SSRF type of an issue. So you can fuzz for that, but then you don't know to whom this data is actually being sent, right? So you see a URL which is being read from the DB, but then you don't know who is being sent to. Maybe it's a service which is owned by you, or it's an external service. It's an untrusted service. You don't really have that information, right? So through static analysis, you will never get to know. But this you can discover only at runtime, right? Because at runtime, an IaaS system will actually hook into those APIs. So it will know when this API is actually called and when this data is actually sent. It can see who that data is being sent to, and it can also look at the data that is sent, and it can analyze and determine if there's anything sensitive there, like for example, a credit card information or UID or some other user's personal information. Okay, and it also performs better than SAST when it comes to dynamic languages. Like it's one thing when you're doing static code analysis on languages like Java, C#, because these are statically typed languages, they're much more predictable. But then when you're looking at dynamic languages like Ruby, Python, Node.js has been a particularly big problem for static analysis because everybody is going to Node, and now they're leaving Node and they're actually going to Go. The hipsters have moved on, but a lot of enterprises are now like a little behind. So now they are actually shifting to Node.js. So you're going to see a lot of JavaScript, and you can have these problems with JavaScript where the static analyzer will look at this and it wouldn't really know what's going on. But then logically, this is actually window.post message, and you're calling it with the asterisk keyword, which is essentially you're sending a broadcast data, which is considered bad. So if it was written like this, your SaaS system would actually report it as a vulnerability for you. But because it's written a little differently, now of course, here I've tried to purposely make it complex. In real world, your developers would not write code like this. But then again, in a large code base, it would end up reaching this level of complexity anyway, right? So because it's just 3 lines, I've tried to push the message across. I've made it a little complex here. So the point I'm making is that for dynamic languages, your SaaS system might not be able to exactly determine what is going on. It cannot do the taint analysis also properly in a lot of cases. So it will miss a lot of vulnerabilities and it will give you a lot of false positives. Okay, and you have some other complications as well, which is, say, XSS is the most common code injection vulnerability. So this information is from the Google's bug bounty program. They have actually paid, I think, $1.2 million just for XSS related bugs, right, as bounties. So XSS is the most common code injection vulnerability. And if you're looking at XSS, then DOM XSS is the most common variant of XSS, okay? And it's the most common variant, and it's also the least tested for variant, ironically. And then when you're looking at DOM XSS, the most common variant of DOM XSS is when you have untrusted data actually coming in a JSON response. Now I've spoken to multiple pen testers, and when they're looking for XSS, they send a payload, they see if it gets reflected in the response. And if it's reflected inside an HTML, then you can easily determine if it's a problem. But what if it gets reflected inside a JSON response, right? Now, how do you determine if this thing is actually a problem? because that would depend on how this JSON is used. Like once this response actually goes to the browser, it depends on whether this JSON is going to be like the value from the JSON, if it's put inside inner text or it's put inside inner HTML, right? Or some other malicious, or not malicious, some other dangerous DOM API. It would depend on that. But as a tester, you don't really have this information, so you cannot say what's happening and you cannot determine if this thing is vulnerable. And in most applications, what you have is your applications take a lot of data from different sources, untrusted data. They put all that in your database. And then when you visit your website, all the data, the information from the database is put inside a JSON and it's sent to the browser, right? And the browser on the client side will take data from this JSON and it'll display it on the page for you. So that is in fact like a stored variant of DOM XSS, and that I would say is the most common variant of DOM XSS. And unless you know what happens inside the browser, you cannot really determine if that's a if you have a DOM XSS there or not. The only option is you will have to start fuzzing every single field in the response. And things like responses are not easy to fuzz. You can fuzz the request very easily, right? But fuzzing the response is a whole different story, right? So some injection points are not easily fuzzable, practically almost impossible to fuzz, just given the amount of time and complexity. So those kind of issues you're never going to discover by using a DAS tool, right? So that's another area where only an IAST will be able to discover problems for you. Okay, so that is about vulnerability detection through IAST. Any questions on that? Whatever you've seen? No? Okay, that's good. I think it was straightforward. All right, so when it comes to your, doing security in the CI/CD and DevSecOps speed, detecting vulnerabilities is just, like one aspect of it, because of course you detect vulnerabilities and then based on that you fail a build, so your developer has to actually fix it, and only then he commits a new code. If no vulnerabilities are detected, they go into production. But then this is all with the assumption that the tool has discovered all vulnerabilities, right? But then the reality is that no matter how good your tooling is, you're still going to miss a lot of vulnerabilities, right? So which means that you're going to have production code which will be vulnerable, even simple vulnerabilities in some cases. So it's very important that you actually have some system which can do attack monitoring and blocking, right? So it's not just about detecting vulnerabilities. You also need something to actually monitor for attacks and block it. So this is where RASP actually comes in. Are you guys familiar with RASP at least? Okay, great. Earlier startup, Immunio or something, yeah, they got acquired also. Yes. Anybody is using RASP in your companies?
So we developed an IDS engine,
Mm-hmm.
which was kind of RASP. We used to call it as stateful decoding.
Mm-hmm. Okay.
Parameters.
Okay. Yeah, I mean, there are two kinds of RASP. One is an actual RASP, other is a marketing RASP. Sometimes, you have one system, and then I've seen it, some companies do it. I wouldn't pick names, where what they actually do is, they like, they write the wording in such a way that they make it some way look like a RASP. So I don't know if this thing falls in that category. Huh?
So that was 2003 years.
Oh, okay, yeah. So that was, okay, fine. That was long back. So, so RASP is where we are moving ahead. So we have one person in the audience who is actually using RASP. The others, have you considered a RASP system? At least somebody has pitched a RASP system to you. You've looked at it? No? Okay, how many of you have a WAF? Okay, that's quite a few of you, a lot more. How many of you have a firewall? This way I'll at least know who is not raising hands at all for anything, right? So I can like subtract that and get the actual numbers. Okay. So a RASP is an evolution of your web application firewall. So I think it's pretty safe to say that if you are hosting an application on the internet, you would have a WAF of some form. Even if you don't have a dedicated WAF, you have your AWS and all, they give you WAF services. Or at the very least, you would be behind Cloudflare, and Cloudflare gives you a WAF service. So you would have some protection like that. But then again, WAF also only looks at your HTTP request and response. So whatever problem your DAS tool faces, in some ways, WAF faces that as well. But a RASP system actually monitors what's happening inside your app. So you can think of RASP as an equivalent of IAST on the protection side, right? So this is where your RASP system sits. So which is, it looks at all the critical APIs, and then if it sees, it looks at what data is going into those APIs, and then it analyzes them. So Ajay Abraham's company was doing something like this, which is They have, for example, parsers written for all the different kinds of critical APIs. For example, if in this case SQL, they have SQL parsers written, high performance SQL parsers. So when they actually see data going into a SQL query, they parse it and then they see if the SQL query has anything malicious in it, right? And if they see anything malicious, they block it. So that is one way of doing it. Some other people, what they do is, before they actually do the parsing, they first see if the data came from an untrusted source. Only if it came from an untrusted source, then they do the parsing and they determine if there is, anything malicious there. So there are slight variations, but this is a commonality, which is the data that's going into the critical API, the RASP system will actually look at it and it will determine if it has anything malicious and then it will block it. Now, this gives you advantages because let's take this case where the client takes an evil payload, it actually base64 encodes it, it sends it to your server. Now, your WAF looks at it. When the WAF is looking at it, it's actually looking at a base64 encoded data, right? It's a simple example. And then when it goes to your server actually base64 decodes it, and then it puts it into a SQL query, right? Now, most WAF systems will miss it. Of course, this is a simple example where it's doing a base64 encoding. There would be complex, cases as well, of course, because I think some WAF systems, what they're doing is they try to look for common forms of encoding and, they try and decode it and then they do filtering. So they try and handle very simple scenarios, but then you'll have more, complex scenarios which will get missed out because the WAF, when it's looking at the data, it's looking at the data in a different, place in your execution cycle. Whereas the RASP looks at the data in the exact same form in which it's going to be used by your application, right? Because when it looks at it just before it gets passed into your SQL query. So it looks at it very accurately, so it can actually do its filtering very accurately. Right, so a RAS system, it actually looks at the base64 decoded data, right? So it will not be able to, the payload will not be able to bypass in this case. Okay, have you heard of MageCart attacks? Yeah, okay. So a few lines of JavaScript code were able to cause a lot of mayhem, and in some cases it's still going on. Different people have been getting affected. It's almost like a disease that gets passed around to different people. So these are some of the companies which got affected, and this is some of the impact in terms of the amount of credit card information that was actually lost by these few lines of JavaScript code. But what is most interesting is this: the duration for which this attack was actually able to go on for. For example, in one case, it actually went on for more than 8 months, which is if somebody got to know they were pregnant when the attack actually took place, they would have had a baby, and the attack was still going on, which is if you think about it, ridiculous. The reason why it went on is because there was no attack monitoring system in place, right? One is, of course, it was not picked up in the regular security testing and code reviews and all of those things, but that's a different problem. But the fact that irrespective of all of that, there should have been something which actually picked up the attack itself. That didn't happen. So the message I'm trying to push is that your protection system should actually run in the place where your code is also running, right? That's the only, because in this case, the attack was on the browser. I mean, JavaScript, which was running in the browser. So you should have had a protection mechanism there. Then it would have got picked up pretty easily, right? So if you don't have it there, you have it at a different location in your network, then you will miss out attacks like this. Okay. So this should be in the browser, but it should not be something which the user installs on their browser, right? But it should be something which the server itself sends. Like, for example, if they had done patching of all their so if they had a JavaScript library which will load first before their regular application code runs, right? And this thing actually hooks into all the DOM APIs, and it sees what type of network calls are being made and to whom they are being made, and if it reports it, if they're being made to a untrusted source, then this would have got picked up much earlier, right? So I'm saying the protection mechanism should run in the same place where your code is running. So for example, if you are writing code which is going to run in a user's browser, then you should also have a protection mechanism sent along with the code, right? Which is also running in the same environment, right? So that's essentially what a RASP does, which is it runs in the same environment where your code is executing, right?
There is a company called Source Defense, which
okay.
implements this as a forward proxy.
Mm-hmm.
They implement a protection in that.
Right, yeah. So they would be injecting their own JavaScript, which runs at the start of the application. Yeah. Okay. So any questions on RASP? Yes, it has to. Yes. Yes. Yeah. So yeah. So there are some concerns there, which is it'll definitely have a performance impact a little bit. That's there. And another concern is also about a lot of RAS systems. The way they work is you have like an engine which runs in, or a sensor which runs inside your app server, and then it'll actually collect some data and it'll send it to their server, which is sitting in their cloud, right? And you might have concerns about your customers' data or your user data actually going to their cloud. That's a concern. Some of them actually have an on-prem solution, like 100% on-prem solution. So you might have to figure those things out, right? So, but there are some concerns in that area in terms of performance. Another thing is also in terms of, will the RAS system actually break some of my functionality? That's another concern, which is a major headache, where the user, like everything works perfectly for you in your UAT and everything. It goes into production. Some functionality is, the user says it's not working for me, and your developer is not able to debug it because he's not able to reproduce it because the behavior has been introduced by RASP, right? So that's another point of concern. But those are trade-offs you'll have to do because of the security benefit that you get, right? So you'll have to decide to see the criticality of the application you're running, right? Based on that, you can decide what is more important for you. And in most RAS systems, you also have the ability to dynamically change the configuration, which is, it'll start with a default set of rules. You can go in and you can see, hey, you know what? I want to turn off my SQL injection protection. Or you can even be very fine-grained, which is to say, I want to turn off SQL injection protection for this parameter in this particular request, right? Because if you see a lot of false positives happening there, you can go and turn off that. So that configurability option is available for you. Right? I think now the URL, it'll say, okay, in this URL, this parameter, I want to whitelist. I don't want my RAS system to monitor it at all. Or you can say this particular endpoint, I don't want my RAS to look at it. If it just let it pass through, right? So you can do those kind of configurations. Okay, so with all of this, all of these benefits, that begs the question, hey, I have DAST and WAF in my environment already. Should I just replace them with IAST and RASP? Well, I would say no, because it's still not. One is, these are evolving technologies. And another thing is, did somebody say something? Okay. And another thing is, there are areas where a DAST or a WAF actually does a better job than your IAST and RASP. One example is, I was talking about coverage earlier, right? So I was talking about the coverage of DAST from a negative perspective, but then there's also a positive aspect to it. Because if you're detecting vulnerabilities through IAST, you're running your functional test cases, then it can only discover vulnerabilities in those sections of the code which are triggered normally through legitimate data, okay? But then a DAS system, because it's sending, like a lot of malicious data and it's sending a lot of unexpected data, it might trigger unique execution paths in your application's code, right? Which might not get triggered by a regular functional test case, and issues in those kind of code paths will not get picked up by your IaaS system, right? Whereas a DAST can pick it up for you. And another thing is, because a DAST works by actually hooking into those critical APIs. Now, if you're using an obscure library for SQL interaction, and if your DAST vendor, your IAST vendor does not have knowledge about that SQL library, then he will not hook into that API at all, right? So you might have a very simple vanilla SQL injection, very easily triggered, like a DAST scanner might pick it up in like a minute. But just because your IaaS system does not recognize that as the SQL API, it will not hook into it, and it will actually go undetected, right? And for example, if you have a IaaS system for Java, and then this Java is actually calling, let's say, a native library from within it, and if that is not hooked by your IaaS system, then vulnerabilities there might get missed out. Or if you have, like, say, 2-3 components, you have a Java service, a Python service, and a Ruby service, but you have put IaaS only on one of those services or 2 of those services, then you have one service which is still not being monitored, and there might be vulnerabilities there, right? And while you are setting up these IaaS system, you might not actually know which services are being invoked by whom. So you might not know that, oh, I have to put IaaS in all these systems as well. So it might get missed out. But a DAS scanner can because it is not concerned about how your application runs. It's just trying to fuzz you from the client side. It might pick up vulnerabilities in those areas, right? So I'm just saying that there's another side to it as well.
One more problem
Mhm.
with IIS and RAS, right? The moment you say that it should run at the same place with the code execution,
Mhm.
right? It is part of the code process,
Right.
right? So then that increases the attack surface.
Oh yeah, that's that is very true, because you are introducing new code into your application, so you're just adding new behavior, and it is not.
XSS blocking that
Oh yeah, because I'm sure you have all seen scenarios like cases where there is a WAF vendor and they have an XSS in their own WAF dashboard. Yeah, so I mean, so we cannot really discount security product companies from not having vulnerabilities in their code. So even though your code might be secure, they might actually introduce some vulnerabilities and make it insecure. So that's a very good point. Although of course they would try to make sure that doesn't happen, but you cannot discount it off as well. It's a very it's an actual reality. Okay, so and then when it comes to WAF and RASP, with all its disadvantages, of course, there are cases where a WAF system might actually perform better, and it comes down. A lot of those things are similar to IAST, which is if the RASP system is not monitoring a particular API, because you're using an obscure library, then it might not block attacks which go there. And another thing is at which layer, at what layer the attack is actually taking place. For example, your RASP system usually runs on your app server, but then you have some infrastructure even before your app server, and attacks against that your RASP system cannot protect you against. But a WAF, because it's the first level of defense in most cases, it can even block against attacks on your web server and so on, right? So you get that protection there. So there are benefits you get with WAF which you don't get with these newer technologies. So the best case scenario is you have both, all four, provided your budget allows you to do that, which depends on how deep your pockets are. But then if it's going to be in mutually exclusive choice, hey, I have only this much money, I'll have to either pick this or that. I would say picking an IAST or a RASP, although I've discussed about the things you will miss out in both cases, just in terms of an overall net benefit, I think the IAST and RASP actually way better. They overall I think they'll give you more value than a DAST and a WAF possibly could. So I'm sorry. There are no. Okay, that's a good question. Let me think about it. I don't know if there's a tool which does all, but there are companies which do them. Like for example, Imperva is a WAF vendor, and they just acquired Privity, which is a RASP vendor, right? So which means now in their portfolio they have both WAF as well as RASP, and they might actually sell it to you as two different products. They'll bill you separately, but at least you get it from the same company.
Another option is to think of things like cloud workers and Cloudflare,
Mhm.
where they're able to inject JavaScript at the edge.
Right. For the client side, yeah, right. So, but they don't do DAST. Right. So his question is like somebody who does DAST as well as IAST and WAF as well as RASP. So I'm not signal sciences. Okay, I don't want to get into details of that. I'm sure I'm not at liberty to talk. I can say positive things about companies, but yeah. And not to say that anything negative, anything bad about signal sciences. They're pretty good, but they're not a DAST and they're not a WAF and RASP combination, right? That they're not. So I don't. To answer that question, I don't think there are any companies I know of like products. Okay, you're talking about IAST, SAST. You have check marks which does IAST as well as SAST. They're not doing DAST though. So, I mean, you'll have to go to the booth, talk to some companies there. I'm sure somebody will have some answers. So, I don't have information there. Huh?
I have a question regarding the example you gave the email function when we're using the DAS system.
Mhm.
Then it wouldn't depend at email.com, right?
Yeah.
So when we're passing the
Yeah, you can do that. You can. So that was a.
That was the client side. Yeah, that validation. The code didn't say it was on the client side. Oh yeah.
So, but then again, you can look for these behaviors and you can actually try and improve your tool, which most dash scanners actually do. But that was just to show, like, push a point that you will have scenarios like that which will not get handled. But what you're saying is true, which is if it was like if for example the field parameter name is email, for example, right? Then the dash scanner, it can just use the parameter name as a hint, and it can actually send payloads in the form of an email. But then again, what if the company is looking for an email address of a particular domain name only? Their corporate domain name. It still wouldn't work, right? Yeah.
I think on this, when you say exclusive choice,
Mhm.
this would be really useful if you were able to say that somehow the findings of your ISP, task runtime security, would be linked with code linkers for that platform. In the sense
If the findings of a dash tool,
of the IS2,
Mhm.
and you're like, okay, these are the table things.
right?
This could be a problem, and somehow it is able to generate linking groups for that platform.
Okay, yeah, that would be nice. That would be nice. Yeah. Yeah. Anyway, so that's it, guys. So with that, I conclude my talk.